Hello everyone, my name is Manoj and I am from Group 16. And the topic we would like to present today is on the vulnerability of face recognition systems towards morphed face attacks. In this paper, we want to discuss how morphed images are being used by attackers to cheat the biometric systems. Morphed images are generated by attackers using some AI engines by blending two or more data subjects and their characteristics into one. So the final morphed image will have all the facial resemblances of all the subjects. If a morphed image is successfully registered in a biometric system, then all the subjects who were used in the morphed image will be verified against the same probe. Because of this, the original subject images will not be able to verify themselves and the link between the subject and probe is severed. This is called a morphed face attack. So in this paper, we try to work on a few vulnerabilities that face biometric systems were facing and also try to explore and investigate a few techniques that can detect these morphed images. We are trying to investigate the following questions in our paper. The first one is what percentage of morphing will, will pose a problem to facial recognition systems for both print and scanning? Will the performance of a facial recognition system be affected by the type of scanners we are using? And the third one is how good are the current morphed face detection algorithms in identifying the fake ones? These questions not only provided answers but also led to many more contributions in this area. We tried to mention a few of those contributions in this paper. And the first one is a new database was created to store all the morphed images obtained from the scanners. An evaluation of different face recognition systems (FRS) will be made concerning morphed images that were scanned. A study is made comparing all the morphed face algorithms with the morphed image database to analyze the stability and applicability. And that's it for my part, and now my friend Pranavi will continue with the presentation. Thank you.
Now let's talk about the reasons on why we chose this topic. While we were checking out different kinds of papers related to this topic, we came across quite a few interesting concepts and techniques that have been involved in these attacks. Uh, Firstly, how much do most face attacks threaten facial recognition system? There are a wide range of attacks that have been going over, and we wanted to know to which extent can these be a threat to the facial recognition system. And to do this, we have also learned that printers and scanners are involved. But once we get into the depth of this, we can talk on how they're used. But I was very curious on to know how scanners have that big of an impact to make a whole attack. Uh, how these morphed images are taken and uh, changed through scanners. And the thirdly, most important is it's very important to know the rate of these attacks, like the false acceptance rate or the false reject rates, or also to which extent can these uh, stand right now that the facial recognition system falls as a positive note of technology protector or on the negative end. So these are the main reasons which led us to choose this topic.
Thank you, Pranavi. So, I'll be talking about what we will be delivering through our research. So, the numerous access control systems use biometric based security mechanisms nowadays. So, since the comparison is simple to acquire and can be done with the conventional cameras acting as a unique sensor, face recognition in particular represents a well established and widely accepted technology. The FRS continues to face a series of threats from printed and scanned modified face assault photos. So the presently suggested morph face attack detection techniques do not work well with digitally morphed photos or with printed and scanned attack samples. So, with the rigorous experimental validations, the work that has therefore revealed the challenges in identifying altered facial photos after print and scan. So, the automated border crossing made possible by biometric passports is among the most common use case for biometrics, which is also known as e-pass. The purpose of ePass is to make an actual document and its owner more closely connected via biometrics, with the goal of eventually lowering the risk of transfer or exploitation of the document by a third party. So, the International Civil Aviation Organization guidelines were followed in the creation of the ePass, which may store metadata in addition to biometric data to meet these requirements. The morphed facial threat recognition system put forth in this article concentrates on morphed facial assault samples in digital form, such as possible for visa applications using electronic photographs or e-pass renewals in New Zealand. Nevertheless, many nations, such as the majority of European Schengen states, will require a printed facial image to be given to the public authority's office during the registration procedure in order to apply for an e-pass. Thank you.